This is BBC One. Now, Patrick Moore with the 20th anniversary celebration in the sky at night.
Years have passed since that picture appeared on the screen in the very first Sky at Night programme. And I well remember my feelings as I saw the opening titles and heard the now familiar Sibelius music. I thought then, my entire career depends upon what I do during the next 15 minutes. So this is a very special programme. The Sky at Night's been running now continuously for 20 years. We haven't missed a month since April 1957. And to mark the occasion, we are delighted to welcome back many of the distinguished people who have joined us in the programme over the years. And you know, if we wanted to choose a time to start our Sky at Night run, I don't think we could have done better than the decade following 1957. Because remember, in those days, things such as quasars and pulsars and black holes were not only unknown, but unsuspected. And then, what about this? The first of all spaceships, Sputnik 1, was launched on the 4th of October 1957, and so the Sky at Night is older than the space age. And of course, the 250-foot radio telescope at George L. Blank played a vital part in tracking that Sputnik, as Sir Bernard Lovell explained when we visited him at George L. Blank the other day.
Sputnik 1 was launched just as the telescope was being finished, and really the first job we did was to use it as a radar instrument to track the carrier rocket. At that time, it was the only instrument in the world which had that capability.
As a moon man, I was excited when the Russians began their lunar probe program, which they did in 1959. And I think one of our most electrifying moments came with Lunik 3 in October of that year, which went right round the moon and sent back the first ever pictures of the far side, which we can never see from the Earth because it's always turned away from us. And this is one. It may look pretty blurred by modern standards, and of course it is, but it was very good indeed by 1959 standards, and it told us a great deal. Now I'd like to show you a couple of globes, both Russian, both sent to me from Moscow. This one round about 1960, and note the large chunk left out, because that area hadn't been covered by Lunik 3, and at that stage we knew nothing about it. And now, of course, we do, because we have got very good maps and pictures of the whole of the moon, both the near side and the far side. So that was the start. And then came the flight of the first spaceman, Yuri Gagarin. And of course, we reported his epic flight in April 1961 in this program, which we recorded at the time. The first man in space, the first spaceman in history. You know, if I'd come on the air in 1957 when we did the first of these Sky at Night programs and said that within 5 years I'd be showing you pictures of the first man to go round the Earth in orbit in a spaceship, well, I think you'd have regarded me as mad. But nevertheless, it has happened. And the great question now is, what is going to happen next? Well, undoubtedly, this flight of Gagarin's is one of the essential preliminaries towards man reaching the moon. But of course, that won't come yet a while. I think myself that the next step is going to be a soft landing of an unmanned, instrumented probe upon the moon's surface, which will act as a real lunar transmitting station. But I have no doubt either that the first manned flight to the moon will take place in the foreseeable future. Well, I wasn't very far wrong, was I? But you can tell how long ago that was from my dark hair and generally youthful appearance. In fact, it was 1961, and that does seem a very long time ago now. Well, alas, Yuri Gagarin was killed in an air crash some years later. I'm sure if he hadn't been, he would have gone to the moon, as he told me he fully expected to do. Well, he was the first of Russia's cosmonauts, and there have been various others, and there's been one space woman, Valentina Tereshkova. But of course, the moon still seemed remote. Then came the Ranger crash landers, and this was the first really good lunar close-up. The orbiters circuited the moon. Do you remember the picture of the century, the crater Copernicus? Then the Russian probes, the lunars, soft landed on the moon. And when the Americans soft-landed their surveyors. And then came the climax. In 1968, Apollo 8 went round the moon. And then in 1969, Neil Armstrong from Apollo 11 made his never-to-be-forgotten one small step onto the Mare Tranquillitatis.
It's one small step for man, one giant leap for mankind.
When Neil Armstrong came to London sometime later and joined us on the sky at night, I asked him what the Earth looked like from the surface of the moon.
The Earth is quite beautiful from space and from the moon. It looks quite small and quite remote, but it's very blue and covered with white lace and of the clouds, and the continents are clearly seen, although they have very little color from that distance.
And so terrestrial isolationism came to an end once and for all. I'll always be glad that the sky at night covered that particular period, because obviously it can never happen again. We covered the later landings too, and we concentrated upon what had been found out about the moon itself. Do you remember David Scott and Jim Irwin at Headley Rill when they drove their moon car over that incredible rock-strewn landscape? And the excitement when Jack Schmitt from Apollo 17 found orange soil at Shorty Crater?
Oh, hey! Wait a minute. Look, weather reflections, I've been fooled. There is orange soil. Well, don't move it till I see it. It's all over. Orange!
Meanwhile, there were plans afoot for exploring the planets. And of course, Mars was a prime target. In 1957, we thought we knew a great deal about it. Vegetation and a nitrogen atmosphere and a thin layer of frost at the poles. It all sounded very nice, and it all turned out to be completely wrong. Well, from Earth, Mars is never easy to study, but in 1965 came Mariner 4, and our first views of the Martian craters. Mariner 6 and 7 followed in 1969, and then in 1971, Mariner 9. And Mars revealed itself as a fantastic world with towering volcanoes and deep valleys. All these led up to the Viking landings of 1976. And we presented several programs about Mars, really concentrating upon it. With me on all these Mars programs were Dr. Geoffrey Eglinton and Dr. Gary Hunt. Gary, what did you think about it all?
Well, of course, the amazing excitement of actually getting a spacecraft to land on Mars and get some very interesting new results from the planet. And of course, once our initial excitement had cleared, we saw the first time an area of deserts, volcanic rock, sand dunes, and a very bright reddish surface.
It was quite incredible. But of course, Geoffrey, you were concerned very largely with the search for life, weren't you? And you still don't know.
Well, the geologists, the chemists, and the biologists were all anxious to see what would happen when they started to analyze that dust. And they scraped the stuff off the surface, first of all, and found this very peculiar action of the material. It behaved rather like a superoxidizing dust, not at all like a living thing. There was still some element of doubt about it. So then they dug a trench,
yes,
and I think you can see it in this picture down in the bottom right-hand corner. They scooped out a small portion a few centimeters deep and then analyzed the dust from the bottom of that trench. And the result from that was almost exactly the same as the surface material. So they're completely in the dark at the moment as to whether there could have been life there in that material.
Well, I wonder, well, of course, Gary, as a meteorologist, you're in a rather better state, aren't you?
Yes, of course, Mars has really shaped up some very interesting weather. Although there's no water actually on the surface in the areas where they've sampled with the landing craft, there are some deep canyons which seem to have frost, and these are melted during the early morning sun and give rise to clouds over small canyon areas, as we actually see in this particular picture. They show up as very bright white streaks over just some of those small crater areas.
Well, one thing we can be certain about is that there's no advanced life upon Mars now. Geoffrey, I wonder if there ever has been.
There could have been, Patrick, because with this new information about the vast amount of water presumably locked up in the poles and perhaps beneath the surface, then in the past there could have been some very wet periods on Mars. If they lasted a long time, then either the primitive Earth chemistry of the Martian type could have started, or else a primitive Martian biology. And then all the evidence eroded completely and erased by the Martian process of oxidation.
And so today we have a world of dust very large, and I think one of the most intriguing pictures of all is this one of a dust storm just starting in the basin of Argyll.
Yes, we've had dust storms in the past, global dust storms in 56, in 1971, again in 73, occur near perihelion on Mars, And this one shows a dust storm beginning, and perhaps Mars may be covered again, totally in dust.
Of course. Oh, it must have been 1959 or 1960, I think. I suggested that Venus might be more welcoming. Now, this is a sketch of Venus. It doesn't show the surface because Venus is covered with a layer of dense atmosphere. And we thought that it might be ocean-covered and possibly with primitive life on the surface. But, alas, no. We found out that the atmosphere of Venus is carbon dioxide, the pressure on the surface is very great, the temperature is something like 1,000 degrees Fahrenheit, and the clouds are made up very largely of sulfuric acid. And so the planet of love is definitely not a very nice place. The climax came in 1975, I think, with those incredible pictures of the surface of Venus obtained by the Russian soft landers. And this was the first one from Venera 9. It shows a gloomy, rock-strewn landscape. Well, we had in fact shown pictures of Venus before, the cloud tops, that's to say, and this is one taken by the first two-planet probe, Mariner 10, which bypassed Venus on its way to Mercury. And it sent back very good photographs of Mercury, showing that that strange little planet is rather like a second moon with a cratered landscape. And you may remember that last month we did in fact show the first definitive maps of Mercury. Then, getting out beyond the inner planets, way beyond Mercury, Venus, the Earth, and Mars, we come to Jupiter, the giant planet in the solar system, a world very unlike the Earth. And this also has been bypassed by probes. The first of them was Pioneer 10 in December 1973. And I think it's fair to say, Gary, that that probe altered all our ideas about Jupiter.
Yes, we've now got very precise information about the magnetic field of Jupiter, which, as you know, is very much stronger than that of the Earth. And of course, we discovered this enormous region of trapped electrons and protons around the planet, which actually spread out for 100 Jupiter radii. And of course, this means that the 4 giant satellites and also the tiny Amalthea are within this region.
It's a highly dangerous place, in fact.
Very dangerous, and also for the spacecraft too. It didn't behave as was programmed during its closest encounter. As a result, the second spacecraft, which went a year later, was sent on a trajectory that went over the North Pole of the planet and now is moving on its way up to Saturn.
And of course the pole is a particularly interesting part of Jupiter.
Yes, we've discovered that the temperature of Jupiter is the same at the pole as it is at the equator. And that's very different from many of the bodies we have in the inner part of the solar system, and means a very strange weather system. And when you look at Jupiter, you notice that the belts and zones, these stripes on the planet, get smaller as you go towards the pole. And when you look close up at the North Pole of Jupiter, you don't find this symmetric flow pattern, you find a series of small eddies.
Now, what about the Great Red Spot?
Well, it's very difficult to put a finger on a precise theory at this moment in time. It's been there for 300 years, but what is an interesting clue are these spots which form in the northern hemisphere. Although dark in colour, some of them have been seen to turn red later in their lifetime.
Now, what's the next step in the exploration of Jupiter?
The next step, of course, is a much more detailed investigation using the sort of instruments that we have on Viking at this moment in time. And this is the Voyager mission, formerly called Mariner Jupiter-Saturn, which gets launched this summer. The first spacecraft reached Jupiter in 1979, will then reach Saturn in about 1980-81, and then move out in the solar system. The second spacecraft, following 3 months behind at Jupiter, reaches Saturn in 81, and then, if working well, will reach Uranus in 1985, and hopefully Neptune in 1989.
It's quite an amazing point, isn't it? We can send rockets now right out as far as Neptune. But of course, even with Neptune, we haven't come to the end of the solar system because there is still Pluto, that strange, erratic little world, which was only discovered as recently as 1930. So I remember that very well. Now, here are 2 photographs of Pluto taken by Dr. Clyde Tombaugh. Those were taken in 1930 by Dr. Tombaugh, who actually discovered Pluto. Well, when he joined me in the sky at night some years ago, I asked him about his search, because he wasn't at all sure where to look. He had to depend upon some calculations made by Percival Lowell, and he didn't know whether or not they were precise.
Well, I was not too familiar with it. I was aware of it, of course, but in view of the earlier previous searches, I was not sure that it was in that neighborhood. And when I embarked upon it, I thought I would go all the way around the sky, searching it very systematically, and see whatever would come out, and whether it was a predicted planet or even some others. And so that was the basis for making the search.
Was it fainter than you expected?
Yes, it was, as far as Lowell's prediction is concerned. He had a magnitude of 12 and expected a planet comparable to Neptune. not quite as large. I think he had a mass assigned of 7 Earth masses. And of course now we know Pluto's much smaller than that.
Neptune and Pluto mark the boundary of the planetary system, but not the solar system itself, because we still have the comets. As I've said, we began our Sky at Night series with a comet, Aaron-Drohon, which was quite reasonably bright. But in my view, Bennett's comet of 1970 was decidedly better. Well, then in 1973, we had Kohoutek's comet. And here's a photograph of it by Paul Doherty, but it wasn't bright, and this really was a grave disappointment, because at one stage, we'd expected it to become really brilliant. Somebody once called it the non-event of the century. But when we come to meteors, we did a rather interesting experiment way back in 1966. We had every reason to believe that one particular meteor shower, the Leonids, might produce a really spectacular display on the night of November the 17th, and that we enlisted the cooperation of viewers. We distributed, I think it was more than 10,000 charts like this, and we asked people to watch in the early hours of the morning and record any meteors they saw, and this we thought was going to be scientifically valuable. Well, in the event, we missed the shower because it only lasted for a few hours and it occurred in our daytime. And I remember one disgruntled viewer wrote to me, "Watch the sky as instructed from midnight until dawn. Meteors from the sky, none. From the wife, plenty." And I can understand how annoyed he felt. But in fact, the experiment was scientifically valuable because it told us what we really wanted to know, that the meteors in the Leonid shower were bunched up instead of being spread all along the orbit. Well, meteor watching is still very largely an amateur study. And I think it's fair to say that astronomy is still one of the very few sciences where the amateur can make a really major contribution. And I'd like to show you my own telescopes down at Chelsea. This is my 12.5-inch reflector. And as you can see, it's in a runoff shed. It's on about azimuth mount, so you can't actually guide it mechanically, and you can't photograph through it. But it was that telescope that I used way back in the 1950s to draw the charts of the moon's edge that the Russians used for their Lunik 3 program. I also got a 15-inch reflector, and this is in a dome, and of course this is equatorially mounted, and you can drive it. Well, the amateur astronomer these days has got to be quite specialized. I'm essentially a moon and planet man, but there are other astronomers who depend upon observing variable stars, or in some cases, the sun. And Commander Hatfield is one of these. Henry, welcome back to the Sky at Night. Well, recently I know you've been concentrating upon the sun.
Yes, and I take pictures of prominences and flares and other things.
Such as this prominence, for example.
Yes, indeed. That I took one day last August. It's not a particularly big prominence, but the sun is at its minimum now in its cycle. Those loopy ones are the best part of 100,000 miles high. They're very big.
Well, I'm sure that amateur astronomy has a never-ending future.
Indeed.
And of course, everybody's got to begin, and I think the very first thing to do when you want to take up astronomy is to learn the star patterns, because the stars become so much more interesting when you find out which is which. This is something we've always concentrated on in the Sky at Night, and we've had our own way of doing it. Our method is to take one or two groups that you can't really miss, and then use them as pointers to the others. We very often started with the Great Bear, or Ursa Major, or the Plough, whatever you call it. And from that, you can find the pole star, which is always in the north, of course. Then, if you follow around the bear's tail, you come to the brilliant orange star, Arcturus. And then, following on still further, you come to Spica in Virgo. And by using the pointers the wrong way, you can come to Leo, the lion, with this bright star, Regulus. And all those stars and constellations are very nicely visible in the evening sky now. Well, that's one of our main pointers. The other one is Orion, which is actually a lot brighter than the Plough, but does have the disadvantage that you can't see it in the summertime. But from Orion, there's so much you can find. Follow the belt downwards, you'll come to Sirius, the dog star. Then we have Procyon, the little dog. And in that general area at the moment, we have the planet Saturn, with its rings still wide open. The twins, Castor and Pollux. And then, right overhead, during evenings in winter, we have the brilliant yellow star, Capella, in the Charioteer. Follow the line of the belt upwards, and you come to Aldebaran in Taurus. And beyond Aldebaran, at the moment, is the brilliant planet Jupiter. And that's the general way in which we do it, and we find that the method does work. And you know, star recognition isn't nearly so difficult as some people imagine. But, obviously, a telescope does help. And in the Sky at Night, we've always done our best to show things direct. In the general way, we've been pretty lucky with the weather, except on one famous occasion, going back again to 1961 with the 50th Sky at Night. We went down to George Holmes Observatory at Brighton, where he had the 24-inch reflector, and what we wanted to do was to show the moon and Saturn direct, but it didn't quite work out that way. Well, of course, when we come to this kind of thing, we are rather dependent upon the weather. In fact, we're entirely so, because if you have clouds, there's very, very little you can do about it. George, what do you think of the prospects now at the moment?
I think we're nearly totally obscured, Patrick.
Do you think it's any good turning on to the general direction of the moon? Frankly, I don't think it is. I can't see a single star at the moment.
It's totally obscured.
We were hoping to see Vega, which is the star, bright star straight above our heads, but even that's gone now. No, we've got to abandon it for a moment.
We're blacked out.
Well, if we can see one star, we'll just get the telescope onto it and give you at least a direct picture of that.
No, we are totally obscured.
Well, there's hope yet. We still have
I can see out here.
Daniel?
But it's going again. It goes before you can get near it.
Well, Altair seems to be about the best bet. I suggest you turn the telescope onto Altair, and just as soon as we get any kind of a picture at all, we can feed it through, so to speak. Any luck?
No, I must be able to see it before I can get on to it.
Trouble, of course. This, of course, is one of the hazards of astronomy. There's just nothing one can do about it at all. There is definitely a lightning over there now, George. Can you see it? It's coming out. Yes, there is the moon. I can see it for the moment. No, it's gone again.
It's gone. However,
infuriating, and nothing one can do. George, can you see anything at all?
Vega!
Can you see Vega?
I don't know whether I can get on it.
Right, the star Vega, which is the thing we wanted to show you. It's a bright blue star right above us, as I said earlier on, and with any luck now, we will be able to get the telescope on it. I can see it quite clearly, and I think we're just about going to have time to show it to you. But, of course, there's still a lot of drifting cloud up there, and we just can't tell whether it's going to be obscured at the critical moment. Of course, you won't see Vega looking large, because no telescope yet built will show a star. Gone. Oh, no.
Just as I got it on the crosswires, it blacked right out.
Oh, absolutely typical. There's nothing we can do about it.
I can't move a 24-inch telescope quicker than that.
No, I'm afraid you can't. So, from Brighton, where the sky is now completely overcast, good night. Good night. They will laugh. Oh, well, we tried. And by the way, that 24-inch telescope is now at the Observatory of the Vatican, where they may possibly have slightly better control over the weather. But let's get back to the sun. When we started in 1957, the sun was near the peak of its cycle of activity, and there were some really major spot groups. But recently, the cycle seems to have been doing some rather peculiar things, and there have been far fewer sunspots than expected, even though the next maximum should be due round about 1980. And incidentally, I wonder how many times on the air I have stressed the danger of turning a telescope or binoculars to the sun and looking direct. It simply isn't safe, even with dark glasses over the object glass or the eyepiece. The only safe way to do it is by projection, as I'm doing here with the 5-inch refractor at my own observatory. There is, in fact, the sun's image, which you can see cast onto a white screen fastened behind the eyepiece. And you can see a couple of sunspots there. But projection is the only safe way. Once, though, on the sky at night, we did turn our cameras straight toward the sun. And this was at Midsummer Day at Stonehenge, when we watched the sun rising over the heel stone. This must be very much the scene that was watched by the makers of Stonehenge so many centuries ago. Then, of course, the monument was a complete circle. Now, only parts of it are left. But the great arch is still there, and the sun will still rise over the heel stone. Through that great arch, the heel stone in the distance, the alignment absolutely perfect as the sun comes up to its rising point over the top of the stone. And there it is. There is the sun rising over the heel stone, as you see it from Stonehenge. And there are very many people who have never actually seen this. I've never myself seen it before, and it really is a superb sight. Stonehenge may, in fact, have been used as an ancient eclipse predictor. And in the sky at night, we've been concerned with total solar eclipses, modern ones, I mean, and we've had one or two rather amusing experiences. I remember once, way back in 1961, I found myself on top of a mountain in Yugoslavia carrying out a live total eclipse commentary. And up there we had some mountain oxen, which in theory had towed our equipment to the top of the mountain, and the Yugoslav producer, unknown to me, was a man with ideas. He decided to train cameras on the oxen and then watch them going to sleep when the sky darkened at totality. And just to make sure that everyone could see them nicely, he floodlit them, and so the result wasn't entirely a success. Then, in 1968, there was a total eclipse visible from Siberia, and the sky at night was there, too. And one man waiting for us was Dr. Ron Madison.
Well, of course, on that occasion, Patrick, you may remember you ran into some difficulty getting a visa, and you'd virtually given up idea of getting to that site. We'd set up our equipment and were waiting just a few hours before the eclipse, and we saw this character coming across the vast Siberian steppes, and we thought we recognized the shape, and we thought, my God, the Russians have one too. But actually it was you, and you arrived on the site, and we were able to get some pretty good observations.
Well, that was quite a moment. And of course, you and I went to Siberia then for 37 seconds of totality. But in 1973, there came the eclipse of the century, the longest one ever, and both Ron and I were on board the ship Monte Umbe off the coast of Africa.
Julia can count down from about 5 seconds before, and we're all right, because we're 6 minutes before 7. I managed to find that 3/4 of a minute spare.
And then we want the end of time, and then we want time before the third contact as well. We'll have that accurately too. No, exactly.
On the morning of June the 30th, we were all rather worried by the hazy conditions. But the sky remained clear enough to give us a good view of the partial phase as it developed. Here's the sun as we saw it a short time before it disappeared. The moon has almost completely covered the disk, and by now, totality is only a matter of minutes away. We all have our cameras ready, and the temperature was dropping markedly. And there's the corona, and there's a brilliant prominence to the side of the sun. This is incredible, the best corona I think I've ever seen in my life. Now the corona seems to be brightening, and those prominences, I can now see 3 prominences and a coronal plume. It's difficult to know just how far the corona extends. I can see a faint sheen round the sun, and now I can actually see 1 or 2 of the brighter stars. There's a strange, eerie quality about the light. Now we can see the diamond ring will be appearing in a minute. We've got over there's the diamond ring, and the diamond ring has appeared. An incredible sight. There it is, the ring has appeared, the corona's vanished, and that is the end of this eclipse of the century. And by Jove, was it worth seeing.
Come on, boys! Hooray!
Well, I don't think either you or I will ever forget that trip, Ron. And of course, solar eclipse observation is valuable.
Yes, indeed. Even though on this particular one it was covered pretty comprehensively from land, sea, spaceborne rockets, and also by Concorde, there were 300 people on that ship all looking at a superb natural spectacle, but some scientists making use of the natural eclipse time. Just a few minutes when the corona, which is only a millionth as bright as the disk of the sun, is visible without any cost.
And of course, one has to take the best possible advantage of it, as you did on that occasion.
Yes, we looked at things like the polarization in the corona, which are perfectly observable under those conditions, and flash spectra and the like, and we got some pretty good results.
Well, it's a great pity that there's no total eclipse visible from England for some time. In fact, the next one is going to be on the 11th of August, 1999. And I do hope, Ron, that you'll join us then, and I can promise you a special Sky at Night program. Some people have commented that we are the Sky at Night program, and the sun is a daytime object. Well, this is perfectly true, but don't forget that the sun is also the nearest star, and the only star we can study in real detail. And without the sun, we still wouldn't know very much about the other stars. There's another point, too. As well as sending us visible light, the sun sends us what we may term invisible radiations, and this leads on to a very important ground from modern astronomy. Now, light may be regarded as a wave motion, and the color of the light depends upon the wavelength. Red's longer than blue, blue's longer than violet, and so on, and you have the familiar rainbow spectrum, as we can see here. But if the wavelength is longer than that of red light, it doesn't affect our eyes, and we can't see it. That is infrared. And when you go beyond the infrared, we come to the radio range. And of course, radio astronomy is now of absolutely crucial importance. When we began the Sky at Night programs in 1957, as we said, the great 250-foot telescope at Georgiou Bank was just about coming into operation. That wasn't the task for which it had been designed, as Sir Bernard Lovell stressed when I went there. How long did you go on tracking satellites?
Well, we tracked satellites for some time, at least the deep space rockets, because we were part of the American Deep Space Network. But now we do very little of that. Occasionally, rockets or space birds go to the moon or Mars. Last year we had a big program on Viking, for example.
But of course the big telescope is designed for exploring things in very deep space, quasars and so on.
Yes, it spends, I suppose, 99.9% of its time now in doing that. And as regards quasars, it played a very important part in the sequence of discoveries leading to those investigations, particularly its linkage, which gave successively more refined angular diameter measurements of these peculiar sources.
Quasars, unknown to us when the Sky at Night started, and I only wish I could tell you what they are. They were identified by their radio emissions, and all I can say is that they appear to be extremely remote and highly luminous. One quasar, recently identified over in Australia, appears to be racing away at the speed of something like 98% of the velocity of light. And also quasars appear to be remarkably luminous, much more so than ordinary galaxies. And don't forget that our galaxy contains something like 100,000 million suns. And so a quasar may well be shining by some process which is absolutely unknown to us. They were identified in 1962, 1963, and I think they must be said to remain the most enigmatical object in the entire universe. But still, we have made some progress, and a lot of the work's been done at Cambridge, where there are telescopes quite unlike the single big dish at Georgiou Bank. For example, there's what's known as the 5-kilometer telescope, and this gives the impression of dishes spread out in a long line. One of the main pioneers of radio astronomy is, of course, the Astronomer Royal, Sir Martin Ryle. And when we went down to Cambridge a few days ago, I asked him what he thought were the most important developments over the last 20 years.
Well, certainly from our view here, it's beginning to understand the physical nature of the radio galaxies and quasars. And this has depended very largely on the ability to map them in great detail. And now, with the 5-kilometer telescope, we are, of course, able to get a resolution, a detail, as good as the best optical telescopes. And this has made it possible to devise the physical mechanisms that must explain them in far greater detail than before. And of course, I suppose this is the best surveyed line in the world, as I've been told. Oh yes, it has to be rather well surveyed to make telescope work at all.
Would you say then there's now a complete link in between optical astronomy and radio astronomy?
I think so, yes. I think all the sources we know most about are ones in which there has been observations over the full wavelength range.
But the telescopes, such as those at Cambridge and Georgiou Bank, we'd still be totally unaware of the existence of quasars. But there are other strange things, too, that have come to light since we started the Sky at Night programs. And in particular, there are pulsars. And these were discovered with a very different kind of telescope, which looks to me rather like a hot field. Actually, the pulsar story began in 1967 with some work carried out by a team headed by Professor Anthony Hewish, who I may say shared a Nobel Prize with Sir Martin Ryle for this work. And in the team was Miss Jocelyn Bell, and now Dr. Jocelyn Bell-Burnell. Delighted to welcome you both back. Tony, can you tell us how the pulsar story started?
Well, I designed that rather strange-looking radio telescope for a special purpose. Here's one of the records from it. And these bumps on the trace here are all caused by radio galaxies. But notice this one in particular, which has a very fluctuating appearance. That's because this radio galaxy is actually a quasar, and it fluctuates like this because of gas clouds passing in front of the source, and because the source is very, very small. Now, the idea of this telescope was to discover all fluctuating sources like this in the sky. We carried out records, and it wasn't long before Jocelyn, who was analyzing miles of this paper, she joined me as a student in 1965 and analyzed about 2 miles of paper like this. She showed me this record and this fluctuating signal here. Now that doesn't look very unusual there, but what's surprising about this source is that sometimes it was in the sky and sometimes it wasn't, and that is unusual. So we decided that we had to have a closer look and to spread the record out and blow it up by using a faster recorder.
Well, now, we arranged this recorder, and Jocelyn made the first successful observations, and I think I should pass over to her now. What do you make of them, Jocelyn?
Very difficult to know what to make of them, Patrick. When I finally succeeded in getting this recording, this is what it looked like.
This is the original one?
This is the original one, yes.
It's a real astronomical history, then?
That's right. There's this pen recording here, and you can see that as the pen goes along, there are impulses, bursts of radio signals. In fact, they're equally spaced. They're not all there. There's the odd gap, but they are typically at this separation, which is 1 1/3 seconds. So we appeared to have a radio source that was sending out flashes of radio waves every 1 1/3 seconds. Suspiciously man-made, actually.
When did you decide that they weren't man-made?
Very quickly, because they went round the sky with the stars. They kept sidereal time, which means that it had to be something going around literally with the stars. I suppose it might have been a satellite in a funny orbit, but we eliminated that. And it couldn't have been anything earthbound, except possibly other astronomers, because they're the only people who keep time with the stars.
And of course, with optical telescopes, you couldn't see anything there at all.
No, not in this case of this one. But after a while, it was discovered that there was a pulsar, believe it or not, in the Crab Nebula.
So, old friend the Crab. What did you make of it then, Tony?
Well, we had thought up to that time that possibly it could be a white dwarf star or a neutron star, but the Crab Nebula observations, which has the star spinning so fast that anything but a neutron star would have come to pieces, we knew for sure that we had to be dealing with these objects. And so this was the first confirmation that neutron stars exist. Now, these are fascinating stars. They're compressed by gravity to a tiny size, and they're really hovering on the brink of becoming black holes.
Well, of course, we always seem to be coming back to the Crab Nebula, don't we? Because this was, they would say, the first identified pulsar. Even now, there's only one other, and the Crab is unique. And as well as sending us radio waves and infrared, the Crab also sends us very short radiations. And this leads us on to yet another development which is taking place in what we may call sky at night time. I suppose most people connect X-rays with hospitals, but remember, X-rays do come from the sky. The trouble is that we can't study them from terra firma because they're blocked out by layers in the Earth's upper atmosphere. And so we couldn't, in fact, do a program about X-ray astronomy in 1957. But after 1962, the entire situation was transformed because then we could use rockets. And when it comes to X-ray astronomy, Britain's always been very much in the forefront. One of the main centres is the University of Leicester, and one of the leaders there is Professor Ken Town. And I asked him how X-ray astronomy all began.
Quite by chance, in 1962, with the launch of a small American rocket with the aim of detecting X-ray fluorescence from the moon. They didn't see anything from the moon, and in fact we still haven't. What they did instead see was a bright, point-like source in the Scorpius region.
And that remains the first and the most famous of all the X-ray sources.
Scorpius X1, that's right.
What exactly is it?
It's now known to be a binary system. In fact, many of the galactic sources of X-rays are binary systems of a rather special kind, where the two stars are very close together, close enough for gas to flow from one to the other. And with the second crucial ingredient, the second star is a collapsed star, probably in the case of Scorpius X1, a neutron star.
I know that a great deal of information has been drawn from the British satellite Ariel 5. I wonder if you could say something about that.
Yes, we're all very excited with the success of Ariel 5. It was launched in 1974 in October. It's still operating perfectly. The intention is to keep it going at least for another year. The major thing that we have just finished doing, in fact, is a new X-ray survey of the whole sky. We've seen now something like 250 sources. We've just issued a catalogue of the high latitude sources, which are mainly extragalactic, and we have a substantial number of new secret galaxies, clusters of galaxies and quasars in that list.
Well, a tremendous amount has been done during the last 15 years, but is it fair to say that X-ray astronomy is still in its infancy?
I think very much so. We're still in the pre-Galileo stage. We're not at the moment able to use imaging telescopes, for example, but that's quite close. Within the next few years, we will be using imaging telescopes. We'll be able to take true pictures of X-ray sources. We'll be able to probe maybe 100 times further out into space. We're already out seeing most distant sources out to about 3,000 million light years, which is, say, 10% of the universe, but we'll be able to probe pretty much throughout to the edges of the known universe within the next few years with the telescopes that are now being built.
From the very short radiations to the very long, or rather we say the intermediate, coming in between visible light and the radio range. This is the infrared side of astronomy, and we're delighted to welcome back Professor Jim Ring, who was one of the leaders in this field. Jim, what's the latest news on infrared astronomy?
Well, as you know, Patrick, normal stars give out mainly visible and ultraviolet light, and so when we pick up infrared radiation, or radiant heat, it's usually coming from the gas and dust around the star. And over the last 10 years, we've learned an awful lot about the way stars interact with this gas and dust and evolve.
What about the infrared telescopes?
Well, in order to work at all in the infrared, you have to build special telescopes. And about 5 years ago, we built the first of the UK infrared telescopes. It's a 60-inch telescope, which we put on a mountaintop here in Tenerife. And you can see that it's well above the clouds and above most of the water vapor that absorbs infrared radiation. Of course, the telescope itself has to be rather special because the mirrors and the structure of the telescope can emit more radiation sometimes than the object you're looking at.
What about the future of telescopes? What about space telescopes, for example?
Well, I think the ultimate in infrared telescopes, of course, is going to come when we can get them right above the atmosphere. If we look at this model here of the space shuttle, and on the back of the shuttle, we have this flying laboratory, and when it's in orbit, the lid opens up, and inside it, we could, for instance, have a cooled infrared telescope like this one, which would let us see perhaps 10 times further than we can see at the moment.
When do you hope that this will go up?
I think by the mid-1980s, to be on the safe side.
And what kinds of objects do you think we're looking at with it?
Well, mainly, I suppose, either protostars, stars at the beginnings of their life, or stars which have evolved and are intimately reacting with the gas and dust around them, or some of the more distant galaxies which give us very interesting infrared objects, or even our old friend, the Crab Nebula. I think when we get an instrument like this, we may very well see some interesting things from the Crab.
The Crab is unique, and people have said there are two kinds of astronomy, the astronomy of the Crab Nebula and the astronomy of everything else. But do you know who named the Crab? He was, in fact, a most remarkable astronomer, the 3rd Earl of Ross, and he drew the Crab Nebula more than a century ago with a telescope he'd made himself. Well, you can still see the telescope there at Burgh Castle, even though it's been out of action now for many years. It was a reflector with a 72-inch metal mirror. And until 1917, it was actually the largest telescope in the entire world. It was found between two stone walls, most extraordinary, cumbersome design. But it really did work, and with it, Lord Ross made a whole series of spectacular discoveries. Burgh Castle was a phenomenon, something which can never be repeated in the history of science. But what about Britain's most famous observatory, that at Greenwich? Now, this was founded in 1675. But in our own time, in the 1950s precise, the big reflectors were taken away from Greenwich because of the state of London with its lights and pollution. In 1972, one of the big telescopes, the 28-inch refractor, came home again to the observatory in Greenwich Park, put back in a replica of the original Onion Dome, which had been destroyed by German firebombs during the war. The new site of the Royal Greenwich Observatory is Hurstmonceux in Sussex, where the lovely old castle is now the administrative headquarters. It's a superb setting with just about the clearest skies in England. And as well as being the time-keeping centre of the world, it's also a very active research observatory. At present, the 98-inch reflector, known as the Isaac Newton telescope, or INT for short, is the largest telescope, although developments are at hand. The director of the observatory, Professor Graham Smith, is of course a pioneer radio astronomer, but nowadays, Graham, I know you're concerned equally with optical work. Yes, well, some of the optical work, fortunately, joins up with radio work through the pulsars. In fact, we had a very interesting expedition to Australia recently to look for the light flashes from the Vela pulsar. So whether you found? Yes, we got them. It's the second optical pulsar. First of all, we had to find the right bit of sky, and the Vela region of sky, in fact, shows that there has been a supernova explosion there. There's all sorts of bits and pieces in the sky. This picture's from a Schmidt telescope taken in Australia. And then, of course, we had to use the big Anglo-Australian telescope, that's the 150-inch, and we had to work for a very long time because the signals are so weak. But we did end up by getting what we call the light curve from the pulsar after adding up the signals for 8 hours. This light curve is really very exciting. It shows two rather rotten-looking bumps from the pulsar, but they are really extremely interesting. Well, of course, this kind of experiment couldn't again have been carried out in 1957 because instruments are now so much more powerful than they were then. And I gather this is the faintest thing ever recorded. Well, it is the faintest thing ever recorded, and it shows how useful it is to get big new telescopes working. And that's, of course, the other thing that we're up to at the observatory. In fact, I've brought along here one of the models that we've been working on because we hope to build a new overseas observatory in the Canary Islands, and this is a model of the very big telescope, 4.2 meters, that's about 168 inches, and it's mounted on Alvaz, rather like your telescope. It's a bit bigger, and we're at the moment in the planning stage for this, but we do hope to be building the observatory starting very soon. Is it going to be in the Canary Islands? In the Canary Islands, on the island of La Palma, and one of the first things we'll do, I'm afraid, is to move the Isaac Newton telescope away from Hurston and put it on top of a rather better observing site. And you think this really is going to be a major step forward? Well, I think so, and we're there on the island with a lot of other European observatories as well. It's a Spanish site, but all European countries are joining in, and I think it's going to be a major centre. Well, certainly, the more large telescopes we have, the better for astronomical research. And of course, the greater the telescope, the further you can probe. And you know, I've often wondered, and who hasn't, whether we are alone in probing the universe. Are there other intelligent beings? Well, certainly not in the solar system. There's no intelligent life on Mars, and no intelligent life in the solar system, except possibly on the Earth. And when you're talking about contacting beings living in other solar systems, some people are likely to say, well, impossible. One man who believes it's certainly not impossible is Professor Carl Sagan. Well, what about the nearest possible civilizations, then? How remote do you think they are?
Well, again, it's very difficult to make an accurate calculation, but when I do my best, and don't claim that anyone can do this very well, I come up with some answer like 300 light years, which is a very large distance. It takes light 300 years to get from there to here, and nothing is going to travel faster than that. So that means that if we were to receive a message via radio from such a civilization, and suppose we were primed to respond immediately, so they would say, hello, you fellows, how are you? And we would immediately say, fine, thank you, how are you? That exchange takes 600 years. It's not what you might call a snappy conversation.
Well, I'm afraid there's no hope of my being able to introduce an extraterrestrial to the Sky at Night yet a while. And yet, I wonder whether the Sky at Night is the only program of its kind anywhere. I have a sort of shrewd suspicion that it may not be. And it could be that somewhere in the universe, some being at this very moment is looking at a television screen and seeing, well, good evening, you're welcome to the Sky. Because I've got my iris. Now, a lot of people have been writing into the Sky Night asking various questions about astronomy. Hello, good evening and welcome to the Sky. To the stars at night. I'm very happy to inflict myself on you like this, but Patrick couldn't be here tonight, so he asked me to step into his shoes. Why not? He's always wearing my suit. So here I am, and he asked me to apologize to you for not being here, but he had to go and show his telescope to the local townsmen and guilds. If they like it, they're going to need him a cover for it. Then tonight he's going to the Palladium for a night with hells and stars. Apparently they're one short, he's going to help them look for it. And what he'll do after that, well, we just don't know. That is a great deal we just don't know. People have often asked me what it's like to be imitated. Well, I can only say that I think it's a great honour. And of course, both Mike Yarwood and Ronnie Barker imitate me very well indeed. Although, personally, I still think that I imitate myself better than they do. But let's come back now to the present Sky at Night. What's going to happen next? Well, I believe that during the next 20 years, the main emphasis is going to be on consolidation, building upon the fundamental discoveries made in the 1960s and the 1970s. But what's the view of the Astronomer Royal? I think it's a fairly obvious development in all the lines of work that are now going on. But of course, at any moment, there may be another discovery of some entirely new particle object, just like the Salvaged came as a complete surprise, and this might well revolutionise things. And Sir Bernard Lovell?
I should think undoubtedly the Large Space Telescope, which the Americans hoped to launch in 1983, by using the Space Shuttle. I think that this will undoubtedly dominate astronomical investigations for the remainder of the centuries. Immense power of penetration into space, giving us access to objects which are far, far fainter than those capable of investigation by earthbound instruments. It is, of course, possible that man will also reach the planets, which will be very exciting.
So, we've had a fascinating 20 years. And the one thing that I really regret is that I personally will never be able to present a sky at night from the surface of the moon. Perhaps my successor will. And I'm sure we are in for really exciting development in the foreseeable future. But you know, I've been lucky all the way through. I've had splendid producers and directors and technicians of all kinds. We've had some of the most distinguished guests in astronomy. We've been able to maintain continuity. And of course, we have been on the air during the most exciting period in the whole history of mankind. And so, we will continue to do what we can to keep you abreast of what is going on in the sky. And I can only hope that you will go on watching us, as so many of you have done over the past 20 years. And so, from all of us in the studio, good night. BBC book by